Good afternoon, everybody. Today's demonstration is on sound and tuning forks. If you take a tuning fork and you strike it, you will see how when the tines are vibrating back and forth, that when the tines are going inward toward each other, you will form a region of a compression between the tines and a rarefaction at the outside region of the tines, as shown in the figure on the left. While the tines are pushing outwards, you will form a compression outside the tines and a rarefaction inside the tines. And with the vibrating tines, you set up a standing sound wave, and then you will hear the sound wave. I have here in front of the camera a stroboscope. So I'll turn this on, and it takes a short moment to warm up, so it will be coming on in probably about 15 seconds. Okay, there it is. It just came on. What I'm going to do is I'm going to strike the tuning fork in front of the stroboscope, and you will see the dramatic back and forth motion. So here is the tuning fork without any motion. It's just still. Now we'll strike the tuning fork, and now you should see the tines moving back and forth in the contrasted light of the stroboscope. So let me do that one more time again. So you should see that dramatic vibration of the tines going back and forth of the tuning fork. Okay, another little demonstration I have is I will turn this off, move this away. I have here a beaker of water, and I will strike the fork again. Now you can see how the water splashes a little. You can see the water moving when I do that. Let me do that again. So there's a distinct vibration of the tines on the tuning fork. So the water splashed a little bit in that demonstration. Now for the next demonstration, we can see how the size of the tuning fork is going to affect the pitch and the frequency. We all remember that the pitch and the frequency are related to each other. The higher the pitch, the higher the frequency. The lower the pitch, the lower the frequency. So I have different size tuning forks here. So here, the small tuning fork, you would expect to have the highest frequency, highest pitch. This is about 1100 hertz. So if I strike this, you should be able to hear that high pitch, high frequency sound. Now I'll take the next fork up. This one is 512 hertz. So now we'll strike it, and you can hear that 512 hertz sound. The next fork is 384 hertz. Notice these tuning forks, the longer they are, the lower the frequency. The similar kinds of behavior with guitar strings, and also a tension in the guitar strings. So now if I strike this 384 hertz tuning fork, you can hear the lower frequency, lower pitch. And then finally, I have a 288 hertz tuning fork. And you can hear that sound in the tuning fork. So you can see here, this demonstrates pitch and frequency. Now of course you will see musicians using tuning forks to tune their instruments like violins, guitars, and the like.